Right, so follow me on from the vernier video. This is a dull test indicator gauge, and basically I'm just going to explain how it works. So you've got this one measures in millimetre. As I said, with the vernier gauge that's in inches, make things much more confusing for me, but never mind. I'm actually having to play with them at the moment because I've never actually owned either of these things in this format. So I'm just taking a few minutes to actually get my head around them first, make sure I fully understand them, because the last thing I want to do is send your piece off for regrinding, re-engineering, to then find out that you completely messed the measurements up and they come back all wrong. And obviously it won't be the engineer's fault who's done it, because they've only done what you've told them to do. So it's important that you understand these things so that you can get it right and not have yourself to blame when it comes back wrong. So yeah, so this one does it in millimetres. This small gauge here in the middle is a full millimetre, which also equates to a full revolution of the larger gauge. And you can use this to measure run out on a brake disc, the run out on a flywheel, the backlash I believe on a differential, and you can also use them to measure a camshaft and how much lift the lobe gives you, and also potentially the duration as well. So basically speaking, if you were to do this on a brake disc, you put it in contact like so that you know for a fact it's engaged because the needle's moved up a little bit. You could then turn this outer ring. If I do it a little bit for you now, it's a bit hard with one hand, not gonna lie. See if I can get the grip on it. Apparently, I don't know. Oh no, there we go. Move that a little bit for you. So you move that round to match the needle, so the needle's always on naught. You put it there yourself, and then you push, and then basically on a brake disc, for example, as I was saying, you'd spin it round. Obviously you can then see exactly how much run out there would be. So as I said, a full revolution equates to a millimetre, and then that means that the centre one goes on 1 mil, because that is the full revolution once, is a millimetre on the little one. And then this outer one here is measuring tenths of a millimetre, and obviously single units as well. So yeah, obviously if I do that, so 70, 80, 90, that's all basically 0.1 of a mil each time. So if I just put a finger on it and stop somewhere random like that, for example, that would be 2 millimeters, 2.36 millimeters, do we think? I think so. So yeah, nice and simple. That is the beauty of most engineering tools. They are massively simple. You just have to understand how to use them and how they work. So now I'm going to go and get measuring.